Today we are going to see differential equation of SHM. See here, suppose F is the force on particle, F is the force, X is the displacement, and M is the mass. Then we can write here F equal to minus kx. Suppose this is equation number 1. But v equal to dx by dt, this is the velocity, and a equal to dv by dx, which is equal to d2x by dt2, this is the acceleration, and therefore we can write here that is F equal to ma, and therefore F equal to m into d2x by dt2. Force can be written F equal to minus kx, also F equal to m into d2x by dt2. Suppose this equation number 2, and if we combine these, if we put the value of force from equation 2 in equation 1, then we can write here m into d2x by dt2 is equal to minus kx, and therefore d2x by dt2 equal to minus k by m into x, and therefore d2x by dt2 plus k by m into x equal to 0, and this is the differential equation of SHM. Heading of our article that we have to obtain the differential equation of SHM. Then we know F is the force, X is the displacement, M is the mass, and therefore we can write F equal to minus kx. This is the original expression. Also F equal to ma. Now here you know v equal to dx by dt and a equal to dv by dx, dv by dt, that means dx d2x by dt2, and if we put this value of acceleration here, then we get F equal to m into d2x by dt2. This is equation number 2. Now we put the value of force m into d2x by dt2 in equation 1 from equation 2 to equation 1, then we get here m into d2x by dt2 equal to minus kx, and therefore d2x by dt2 equal to minus k by m into x. Now therefore d2x by dt2 to this side plus k by m into x equal to 0. This is the differential equation of SHM. This is the heading of our article. Now we will see next article. Acceleration, velocity, and displacement in SHM. Acceleration, velocity, and displacement in SHM. Now here you see, you know that is d2x by dt2 equal to minus k by m into x. This is equation number 1. Also in SHM we have proved acceleration is equal to minus omega square x. This is equation number 2. We put this value here, and therefore we can write here d2x by dt2 equal to minus omega square x. Suppose this is equation number 3. Now we write here d2x by dt2 equal to ddt of dx by dt, and which is equal to dv by dt. Also we can write this dv by dt as dv by dx into dx by dt, and which is equal to v. Dx by dt means v into dv by dx. That means value of d2x by dt2 is equal to v into dv by dx, Suppose this is equation number 4 and we put this value v into dv by dx in equation 3. Therefore, we get here v into dv by dx equal to minus omega square x, and therefore dx to this side we write v into dv is equal to minus omega square x into dx. Now we integrate both sides. Integrating both sides, we write here integration of v into dv is equal to integration minus omega square x dx, and we solve this integration. V square upon 2 is equal to minus omega square x square upon 2 plus c. Suppose this is equation number 5. Now here we have to obtain the value of c, that is constant of integration. For that we put the extreme conditions. Here suppose this is the SHM, then at x equal to plus a or x equal to minus a at both extremities, right and left, here we get v equal to 0. If we put this value here, then we get here 0 is equal to minus omega square a square upon 2 plus c, and therefore c is equal to omega square a square upon 2. Suppose this is equation number 6, and we put this value of c from equation 6 in equation 5, and therefore we get here v square upon 2 is equal to minus omega square x square upon 2 plus value of c omega square a square upon 2. Here you see, therefore 2 gets cancelled and we get here v square is equal to, we take omega square common, then omega square into a square minus x square, or we can write here v is equal to plus or minus omega square root a square minus x square. Suppose this is equation 7 and this equation 7 gives velocity. Now here we have to obtain the displacement. You know v equal to dx by dt. Therefore we put this value in equation 7. We get here dx by dt is equal to omega root a square minus x square. Now we rearrange this. Dx upon square root a square minus x square, which is equal to omega dt. And now again we integrate both sides. Integrating both sides, we get here integration dx upon square root a square minus x square is equal to integration omega dt, and this is the direct formula. We write here the value of this, that is sine inverse x upon a is equal to omega t plus alpha, where this alpha is constant of integration here, and therefore we write here x upon a is equal to sine omega t plus alpha, and therefore x equal to a sine omega t plus alpha. Suppose this is equation number 8. That means we have obtained the displacement in equation number 8. It is heading of article, that is acceleration, velocity and displacement. Here starting from acceleration, we have start from acceleration. Acceleration is given by minus omega square x, dx by dt equal to minus omega square x. Now we have to obtain the velocity. For that, how we rearrange this? Left hand side, d2x by dt2 is equal to ddt of dx by dt is equal to dv by dt. Now again we rearrange dv by dx into dx by dt. This dx gets cancelled, means dv by dt as it is, and again dx by dt equal to v into dv by dx. That means we obtained in equation 4, we cancelled the time factor and we have written equation in v and dx. Now we put this value of acceleration v into dv by dx from equation 4 in equation 3. We get v into dv by dx is equal to minus omega square x, and therefore v dv dx to this side minus omega square x dx. Now integrating both sides, integration v dv is equal to integration minus omega square x dx, and integration of this v dv means v square upon 2 is equal to minus omega square x square upon 2. For that, you know this formula, integration of x dx is equal to, we write x raised to n plus 1 upon n plus 1. This is the basic formula we have used here. instead of v we have x, we have v raised to 1, therefore v raised to 1 plus 1. See here, 1 plus 1 upon 1 plus 1 means v square upon 2. This is the basic formula you needed. Now we consider v square upon 2 is equal to minus omega square x square upon 2 plus c. Now this c is the constant of integration. We have to obtain its value, and for that we put the extreme conditions. Extreme conditions means we consider at right side and left side. These are two extremities. At right side x equal to plus a and v equal to 0, or on left side x equal to minus a and v equal to 0. We put any one in this. Then we get here v is 0 on both sides. V square 0 equal to minus omega square x is equal to plus a or minus a square is a square upon 2 plus c, and therefore c is equal to omega square a square upon 2. This is equation 6. We put equation 6 in equation 5. We get v square upon 2 is equal to minus omega square x square upon 2 plus omega square a square upon 2. This 2 totally gets cancelled. We get v square equal to, we take omega square as a common, then a square minus x square, and therefore v equal to plus or minus omega root a square minus x square. This is the equation for velocity. That means from starting from equation of acceleration, we have reached up to velocity. Now to obtain this displacement, we write here v equal to dx by dt, v equal to dx by dt. Now we put v equal to dx by dt in this equation. We get dx by dt equal to omega root a square minus x square. Now plus minus we cancel this. That means we write only magnitude here. Then dx upon to this side root dx a square minus x square, and dt to this side omega dt. Now again like this, integrating both sides, integration dx upon root a square minus x square equal to integration omega dt. Now this is the direct formula. That means whenever integration of dx upon root a square minus x square is equal to sine inverse x upon a. This is the direct formula in integration. You learn this in mathematics. Then integration dx upon root a square minus x square, we get here sine inverse x upon a, and integration of omega dt means omega t plus alpha, and here again alpha is the constant of integration. Now here x upon a equal to sine to this side, sine omega t plus alpha, and therefore x equal to a sine omega t plus alpha. We reach to the displacement. Now starting from acceleration, we have obtained the formulas for velocity and acceleration in equation 7 and equation 8. Now this we consider here, that is displacement. Displacement from equation 8, we can consider here two cases. Case 1, when particle starts from mean position. When particle starts from mean position, then x equal to, we consider here alpha is equal to 0. Alpha is equal to 0. If we put alpha equal to 0 in this equation, then we get here x equal to a sine omega t. A sine omega t. We can use only this expression for displacement. And case 2, we consider here when particle starts from extreme position, then alpha is equal to pi by 2 or 90 degree. Then we can get here x equal to a sine omega t plus pi by 2, or we get here x equal to a cos omega t. This is equation number 10. We use this equation number 10 when particle starts from extreme position. That means when particle starts from mean position, displacement can be given, that is x equal to a sine omega t, and when particle starts from extreme position, then displacement can be given x equal to a cos omega t. This is the velocity, acceleration and displacement in case of the particle starting from mean position and from extreme position. We consider this. Now here you see, that is we use these equations whenever we are going to solve the examples all about this acceleration, velocity and displacement